Hello friends. So this is a beautiful problem and consider the concept of circular motion and projectile motion in same problem. So it says a pendulum bob is suspended by a string of length L. From its lowest position it is thrown with a horizontal velocity v0 such that somewhere a string slacks and particle passes through the point of suspension following the parabolic trajectory. And then we have to find the velocity v0. So what is given in this problem? So let us try to first analyze this problem. So we have a pendulum bob and this bob is initially given a velocity v0 when this is at lowest position. So what will happen? This pendulum ball will move and it will go up. So question says when it reaches somewhere like here at this position, the string becomes slacked. So at this point, let us say a string slacks, this means tension becomes zero. So tension becomes zero at this point. So this is the point of suspension. So let us say this angle, the angle from the vertical, so this angle, let us say this angle is theta. So at this point what is happening, this moves in a projectile motion. And question said it passes through the point of suspension. So at this point tension becomes zero. So once tension becomes zero, the string slacks and then this basically follow a projectile path. And this projectile path passes through the point of suspension. So using this we have to find velocity v0. Let's say at this point velocity is v. So let us say what are the things that is given. So let's say mass of the bob is given m and length of this string is also given. This is L. So this length of a string is given L. Initial velocity v0 is given. At this point velocity I have assumed this velocity is v, which is not given. And then we have also assumed this angle theta. And we have to find v0. v0 is given initially, but finally we have to find v0. And these two are also unknown. So theta and v are unknown. So now we have to solve this problem. So what are the concepts that you will be using to solve this problem? So first concept, because this is moving in a circular motion, so you have to write force towards the center, that is in the radial direction, is equals to mass into acceleration in the radial direction. This is the first equation you will have. And the second equation, since this is moving in a parabola, so you have to write x direction equation in parabola and y direction equation in parabola. So if this is moving in parabola, what is x equation and what is y equation? And you will also need to write energy conservation. So you will also need to write energy conservation. So you use these three equations. So pause this video, write these three equations and try to solve for v0. Okay, let us solve this problem now. So first equation is circular motion equation. So what are the forces that is acting? So on this mass, mg is acting in the downward direction. Tension is acting in this direction. So component of mg, so this angle is theta. So this angle will be, so this angle is theta, so this angle will be 90 minus theta. So mg cos 90 minus theta, this will be mg sin theta. And in this direction, in the radial direction, you will have mg cos theta. So in this direction, force you will have, that is mg cos theta. So force towards the center is T plus mg cos theta is equals to mv square by r. R is basically in this case length. And it is given that the tension becomes 0 at this point. So from here you will have V square is equals to GL cos theta. So this is my equation number 1. Now next equation I can get from energy conservation. So let us apply energy conservation. So if I write equation for energy conservation, so this is energy conservation. So we can write, what I can write, total initial energy is half mv naught square. Only kinetic energy was there. And final kinetic energy is half mv square. But we will have some potential energy. How much will be the potential energy? So this height will be L cos theta. You can verify yourself. And this height is L. So total height will be L plus L cos theta. So potential energy will be mgh, and h is nothing but L plus L cos theta, that is L times 1 plus cos theta. So from here you can write V naught square is equals to, mass basically gets cancelled, and 2 you can take that side, so you will have V square plus 2gl 1 plus cos theta. You can also plug the value of V square. V square is basically GL cos theta from equation 1. So you can write V naught square is equals to V square, which is basically GL cos theta. So this is GL cos theta plus 2GL cos theta. GL cos theta plus 2GL plus 2GL cos theta. So this becomes, if you take GL common, so this becomes 2 plus 3 cos theta. So now this is equation for V naught square. So let us call equation number 2. Now the third equation, that will come from parabola. So that is, I have to write equation of motion in x direction and y direction, because this is moving in parabola. So this velocity is v. So this velocity is v. So it will have two components. One component in this direction. So this is y component of velocity, and this will be x component of velocity. So this is vx. So this angle, you can verify yourself, this angle will be theta. So this side we will have v cos theta. So you can write here basically. So this is, let us say, v by, and this is vx. So vx will be, you can say vx in this case will be v cos theta, and v by will be v sin theta, and that is in the upward direction. So up. So let us write equation of motion. You can write equation of motion in x direction. So x direction, what is total distance that it has covered? So this is the total distance. So this distance is the total distance that it has covered. So this distance is how much? So this distance is L sin theta. So I can apply S is equals to U2 plus half AT square. So distance is L sin theta. And initial velocity in x direction is v cos theta time, let's say after t time this crosses this point of suspension. And there is no acceleration in this case. So half AT square term becomes 0. So from here you can write t is equals to L sin theta, and this divided by v cos theta. So we will use this time. So let us write equation of motion in the y direction. So what is the distance that is covered in the y direction? This is simply L cos theta. So we can write L cos theta is equals to, distance is covered downward but the initial velocity is upward. So let us put this as a negative. So downward direction, distance has been covered in the downward direction. So what I am saying is, upward I am taking positive. So anything that is downward will be negative. So minus L cos theta. Initial velocity is b sin theta ut, and the acceleration in the downward direction, that's why this is negative sign, minus half gt square. But we know time, so we can plug the value of time, b sin theta, and time is nothing but L sin theta divided by b cos theta. So this is my time, minus half gt square. Time is how much? L sin theta divided by b cos theta. So square of this. So from here you can see, so this will become L cos theta, and this b gets cancelled out. So this b and this b gets cancelled out. So you will have L sin square theta by cos theta minus half z, and this will become L square sin square theta divided by b square cos square theta. Now we already calculated the value of this term, that is b square. B square was what? B square was this term, that is gl cos theta. So we can plug this value here. So now if I plug b square equals to gl cos theta, so this will be L sin square theta divided by cos theta minus half z L square sin square theta, and v square is nothing but gl cos theta. So this becomes gl cos theta, and this multiplied by cos square theta. So you see this term L throughout gets cancelled out. So you will have L square, and here you have L, and this G and this G also gets cancelled out. So now you have expression only in terms of theta. So minus cos theta and minus sin square theta. Let's take cos theta here in the denominator. So this will become cos square theta. No, this is equal to sign. So there is an equality sign. So this is not negative. So this is equal to. So what we can do is, let's put this at L equal to sign, cos sin square theta divided by cos theta, and this will be minus half sin square theta by cos square theta, that is tan square theta divided by cos theta. So let us multiply by cos theta throughout. So we will have, this was basically cos theta. So if you multiply by this cos theta, so this will becomes minus cos square theta, and this is, let's take this sin square theta this side. So we'll have minus sin square theta is equals to minus half tan square theta, and sin square theta plus cos square theta equals to 1. So now I can write, here. So this will be minus 1 is equals to minus half tan square theta. So in other words, we can say tan square theta is equals to 2. So now tan theta is equals to root 2. So this means when this makes an angle of tan theta is equals to root 2, the string becomes slack. Now at this point of time we have to calculate V naught. What was the expression for V naught? So this was the expression for V naught. That is V naught is equals to GL, V naught square is equals to GL times 2 plus 3 cos theta. So this expression I can use, that is V naught square is equals to GL 2 plus 3 cos theta. Now you know basically tan theta is equals to root 2. So this distance is root 2 and this is 1. So this is root 3 and this angle is theta. So now we can put B square is equals to ZL, and 2 plus 3 cos theta will be 1 by root 3. So this will be V naught square and this is 2 plus root 3. So ZL times 2 plus root 3. So in this case, the final velocity, the initial velocity v naught square is equals to GL2 plus root 3. So this will be the answer for this problem. Now question for you. So basically in this case, what we have done is, during the parabolic motion, we have considered velocity in y direction and x direction, and we have applied equation of motion in x direction and y direction. You can also apply equation of motion along the inclined plane. So what you can do is, you can take this inclined plane and you can take the component of velocity, one along the inclined plane and one along the perpendicular direction of this inclined plane. Basically this is not an inclined plane. So this is the line joining between the point of suspension and the ball from where it loses the tension. So try to write equation of motion along this incline, and that is, you have to take the component of velocity and component of gravity and try to solve this problem. And if you are able to solve this, please comment in the comment box. And I hope you enjoyed this video, and I will see you in the next video. If you like my videos, please share and subscribe to my channel. Thank you.